Hey everyone, I want to welcome you again to our MEE 425 aircraft design course. Once again, my name is Sid Gunasekaran, and this week we'll be discussing our material through online, through videos, and we'll be back in class next week. And I hope these series of videos that I'm going to post will give you a good overview of this course, the course outline, the course schedule, how the course is structured, the assignments, the expectations, etc. As well as there will be videos on aircraft performance and the first assignment, which will be on the review of aircraft performance itself. All right, let's get started. So in this video, I hope I can get through talking about the course introductions, where we discuss the objectives, the course structure, some of the learning resources, the software we will use, and finally, how the course is laid out across our semester in the course schedule. Uh, all of these information will be in your syllabus as well. I strongly urge you to go through the syllabus, read through the syllabus so that you know what you're getting yourself into. And in this video, hopefully we'll talk about the design mindset. And I think that I'll save the design process for the next video because it may get a bit long. All right, let's jump in. Let's start with the course objectives because, I always discuss this with my students in any and all classes that I teach because course objectives are kind of like our goals. It kind of gives you a big picture view of what we are going to do. And it's important that we all are on the same page on what exactly that we are going to do this semester. All right. So let's start with course objectives. Now, I'm going to walk you through a series of steps. Again, you can see that the process or the objectives here kind of mirrors the design process, which makes sense, right? And our objective is to design an aircraft. But again, it's not as straightforward as, just say, hey, let's create a wing and a tail. But we have to step through some certain objectives, sub-objectives before we actually end up designing an aircraft. Um, so what are we going to start with is making sure that we design an aircraft around a mission. So that is going to be our first step is how we can actually design an aircraft based on a certain specification, certain requirements. So, and how do we design that, right? So we're gonna, one of the objectives to learn how to set requirements and set constraints and specifications. And after that, so once we establish those requirements, well, there may be different configurations that can achieve those requirements. And we have to understand and analyze how or what configuration is best suited for those requirements and those specifications, right? There's a series of steps that we'll walk through as well. So once we achieve a configuration, then we got to look at, all right, how big should our wing be? How big should our engines be, right? Because we cannot blindly select the wing area and the engine requirements without knowing uh, whether or not those metrics, such as again wing area and engine performance, meets the overall mission requirements and specifications that we set out to do in the first place, right? So we do what we call a constraint analysis or constraint diagram and find our design point. Now, once we find our design point, then we move on to what is called conceptual sizing. This is where we get an idea of, how the airplane will look like. All right. This is the first time you will actually see a physical, drawing of your aircraft, right? We will put that together. Once again, there are multiple steps involved in here. That's exactly what this course is about. All right. So then what we're going to do, um, once we have a conceptual aircraft on paper, now, it is what we're going to do is we're going to look at, all right, so what is the aerodynamics here? What kind of airfoils that we select? What kind of engines and where should we place them? And, how do we size our control surfaces, right? All of these things we got to talk about it, right? And that's knowing how to do that is a fundamental to aircraft design because when we think about aircraft, we're not just looking at one aspect of the design. It's an airplane is a system in general. So we gotta look at this through a systems level mindset, right? We gotta look at how do we design an entire system that we call this aircraft, and not just one specific part of the aircraft, right? But again, we'll talk more about this when we talk about our design mindset and the process. Design in general, it doesn't really, this doesn't really apply to just aircraft design. Design in general is an iterative process, right? So that means if, and also there's a lot of trade-offs for this. So what that means is that, well, if something increases, then something else will decrease. And it is about finding that perfect balance that gets you what you're looking for from the aircraft, right? We don't want the aircraft to perform way more than what mission requires to, because that will be a waste of weight and fuel. We just want the aircraft to perform exactly what we want to do. We don't want it to do way overperform, and we don't want it to way underperform. Okay, so we wanted to perform just right. So that's where the trade-offs and the analysis comes into play, right? The beauty of our doing taking this course at UD is that we have a state-of-the-art flight simulator, which you may have seen, which is our Merlin flight simulator. So we are going to use our flight simulator to get a first-hand experience of how the aircraft that you're designing performs. Right. And not only that, like, we'll get feedback from test pilots and all of that. We'll talk about more about this. So knowing how to model the aircraft in our flight simulator is one of the objectives. But not only that, but knowing how to troubleshoot the design on, the flight simulator is one of our, objectives. And again, I have this gray block here. If time permits, I've had students do this in some of the previous semesters, where we can actually 3D print your aircraft and test it in the wind tunnel and see if the experimental data compares with your analysis, right? But that is like really cool. But again, sometimes we may run out of time. But if time permits, that's something that we can really do and kind of really, gives you a good overview of the design process in general. Right. Now you can see that, in this diagram, there's a lot of iterations involved. That is just the nature of the game. That is, if anytime we do a homework, we just not done with the homework once you submit it, because when things change down the road, you have to go back to the previous homework and iterate on it. And that is just the nature of the process. That's why, it just requires a different kind of thinking when compared to other conventional courses, because in other courses, once you're done with the homework, you're done. You may never look back at it. But we can't do that in this assignment, in this course, because everything feed off of on each other, right? When you find out your weight is a little bit more heavier than you initially thought, we have to go back and put the correct weight in, and that may change your design. And we got to do this iterations until a design converges. It is just the nature of the process, and it requires patience, requires effort, and that is our objectives right now. We want you to understand the the nature, like, and what it takes to design an aircraft. Now, it's not, some of it is straightforward, but the process is not straightforward. It requires a lot of iterations. All right. So hopefully you get an idea of what we're going to do and the objectives. So, and the way we're going to structure this course is that, there is a lot of work to do. But we're going to do in teams of two maximum, because I want you to, want each and every one of you to walk away with a good understanding of what it takes to design an aircraft. While doing it independently may take a long time, which is why, like, I want you to work in teams. But that also, you also need to make sure that you are pulling your own weight in the team, and not let the other team member, do all the work, right? Because it is a lot of work, which also means that your individual score depends on your team performance. All right. So you gotta make sure that you're on top of all the assignments, all the, resubmissions and iterations, etc. Okay. That's very, very important. Right. So there's 8 chapters overall. Again, the process here is laid out in the same manner that we are going to go through the design process. And we are going to make sure that we finish each step one by one before it culminates into a design. And once we get a design, as I mentioned, we got to go back and iterate. So this process allows us to not only arrive at a design, but arrive at a good design that is going to work in the flight simulator with few iterations. All right. So that is the overall goal, and that's how I structured this course. So there are 8 chapters overall, as listed here. We're going to spend 2 weeks per chapter. The first week on lectures, like, if you're talking about aircraft performance, this week I'll be covering all the theory and the equations and all of that. And the following week, next week, we'll be actually doing some work in the classes where you will actually get class time to work on the homework because, again, it is a lot. There's a lot to do, right? And we're going to follow the same format for all the other chapters as well. The first week of that chapter will be theory and discussions and understanding what we have to do. And the following week, you'll have classwork. Now, classwork is where you get to actually get your hands dirty and do the math, do the analysis, kind of like doing the homework. But it's very important that you come to class for that classwork because we are going to discuss what really goes into the assignments, how to approach a certain step in the process, right? You cannot, I emphasize again, in classwork, we are going to discuss things that are integral to finishing your assignments and integral to the process. All right. So class attendance is is not optional. You absolutely need to attend the class. I've had students fail miserably because they fail to attend the class consecutively. And, our process, again, we have a limited time. So we are going to, go through this at a slightly faster pace. And if you don't understand where we are in the process and what we did before, what you do now is not going to make any sense whatsoever. All right. Because there is a fine thread that connects every step of the process. And if you don't understand what happened before, you're not going to understand what happens now, and you're not going to understand what happens next. So I would not skip class because it's going to be a disaster. If you don't understand what's happening, everything that's going to come after that, you're not going to get it. And you're going to actually have to work twice as hard to catch up. And it is, I strongly suggest not skipping any class. Okay. So it is very vital. Okay. All right. And we're going to do homework in bi-weekly submissions. Again, it's going to be a group submission. Um, but you want to make sure that, all our assignments will be turned in on Tuesday night around midnight and every Tuesdays. Um, and then, like, one thing that I didn't actually put it in here is on Thursday, every 2 weeks we'll have a quiz on every chapter. All right. So say, 3 weeks from now, we'll be finishing aircraft performance chapter. So we'll have a quiz on aircraft performance. Again, this is just to make sure it's more for my benefit than yours, because, like, I want to make sure that, you all following the concepts, you understanding what you're doing. So the quiz is not going to take that much weight, maybe 20 points. That's pretty much it. So, okay. Learning resources. There's a ton of learning resources for you available. Um, Once again, like, I really like this code. The more of what we do, again, we're not going to follow a single textbook, because if you look at aircraft design textbooks, there are many of them, but not all textbooks have follow the same process. Um, Mainly, that is a good reason for it, because, sometimes certain textbooks show the design process for a general aviation aircraft, whereas some textbooks follow the process for fighter aircraft, right? Now, I'm not going to ask you to ask you to select a single type of aircraft for you to design, because I think that just spoils the fun, right? I want you to design the aircraft that you want to design. Um, but I also want to make sure that you have all the resources you need to do that. All right. So, in order to do that, we have to rely on multiple resources because if I just prescribe a textbook, that textbook can only talk about designing a fighter. But those of you who want to design a general aviation, you may miss out on some of the things that you need. All right. So we're going to look at a plethora of resources. All of them will be available to you via Google Drive. Right. But more of what you'll be doing is going through these resources and, and pulling out what you need. All right. I'm I'll mention this throughout the semester. Uh, I am more like a guide in this process. I'll show you the path that you can take that'll lead you to a successful design, but it's up to you to take those paths. It's you have to walk those paths. Um, and it is a very the experience of designing an aircraft, you're gonna face some challenges, some time constraints and all of that. But it's a very rewarding process. At the end of this, you will get an aircraft that flies, that aircraft that you call your own. Uh, you can talk to some of the students who've been through this process. While the process itself is hard, that's why working as a team is very helpful. But man, when you enter the sim, when you fly your aircraft for the first time, that is a feeling like no other. So anyway, in order to get that, we have to rely on multiple resources, and that's what it is. And I listed all of these resources in the syllabus. You can look a look. Um, but like say, if you find yourself designing aircraft for your living, and you need a textbook to keep in your library. I recommend this textbook, Fundamentals of Aircraft Design and Airship Design by Nikolai and Kirshner. While this is slightly inclined towards fighter aircraft, the process listed in this book can be used for multiple aircraft designs as well, multiple type of aircraft as well. Okay. So we're going to take about 60% of what's discussed in this book. The other 40 we have to pull from whatever the type of aircraft you end up designing. All right. So there are, again, here are the aircraft type and the relevant textbooks for different types. And if you go to this QR code, and here's a link, you will find these uh, resources on this drive. So again, the free to download, make sure to get what you need. All right. And we'll talk more about this. Right now, all you need to know is there are a set of resources available for you down the road. Okay. All right. So all of these, I listed in the syllabus. We're gonna make sure that we refer to them when the time comes. Um, yeah, right. And also it's a good set of resources to have just in case you find yourself teaching or doing aircraft design for your living. All right. In terms of software, again, we're gonna do a lot of design. Lot of the design takes place in MATLAB, Excel, but we're also gonna use basic airfoil simulation tools like Xfoil, XFLR5. MATLAB will be used a lot. If we get to the stage where we are doing 3D model of your design, SolidWorks is very helpful. But what we're going to do is we're not going to make a new design in SolidWorks. We are going to create an aircraft, your aircraft in a software called OpenVSP. Those of you who have used OpenVSP know it's a very useful tool for aircraft design. Not only you can design your aircraft, you can actually perform aerodynamic analysis on that and understand if you get the CL that you're looking for, the CD, the L over D, the efficiency, and all of that, we can understand from the OpenBSP analysis. And it's a very powerful software that can do a lot of things. All right. So that's software. And then let's move on to the schedule. So here's a schedule. Now, the schedule is not set in stone. This is just for you to get an idea of how the semester is going to progress. And if there's any changes, I'll make sure to update in the schedule so that, we're all on the same page. All right. So this is January, right? Of course, first week I'll be out, and I'll be providing online lectures like this that we will watch for the first week. And then the next week, we'll be doing in class. Unfortunately, I'll be out of town but that Thursday next week as well because I have another conference that I have to attend where I'm presenting. It's something. This semester is a little bit weird because ideally all of these, like in the previous years, all these conferences will happen ahead of the first week of classes, but this time it all fell on the first 2 weeks. But I'll be there on Tuesday of next week. Well, we'll make sure to discuss what we are going to do. And, any question, I'll answer any questions that you may have on the aircraft performance. So that's why it's vital that you watch these videos to, basically get started on performance on the first assignment so that, again, you'll have everything you need. The first homework will be due on, 27th. So that is on Tuesday, right? And then the following Thursday, we'll have a quiz on aircraft performance. So that's how January looks like. And then if we forward to February, right? Again, you'll see the pattern continues. We are going to talk about a concept and the chapter for that week, and then we'll actually work on the assignments for the next week. But sometimes there will be some bleed over as well. I'll tell you that right now because depending on how we progress, I don't, I'm not somebody who like to rush the lectures and the theory and our discussions just to finish it. You know, I want you to understand, be comfortable with the concepts that we are talking about. So that means if there are a lot of questions, I'm okay with that. Now, I welcome it. In fact, like I want you to ask a lot of questions. But if that happens, that there may be a little bit of bleed over into our class time in the following week. But it's not going to take the entire class. Again, we'll play it by ear. We'll make sure to accommodate, balance the workload between the theory and the discussions and the assignments and in the analysis that needs to happen. All right. So we're going to follow the same pattern. Again, you can actually see, uh, you can talk about theory and then classwork, theory and classwork. All the homeworks will be due on Tuesdays. And then the following Thursday, we'll have a quiz on the chapter that we talked about in the previous week. All right. March, we got a couple of breaks coming up. We got the spring break and Easter break. And April is going to be busy. April, the entire, as you can see, like half of April, almost all of April, you will be spending time putting your design in the simulator and evaluating the design and making sure that it actually works as intended and performs as intended because in the finals week, which is the second week of May, we are going to have test pilots from the Wright-Patterson Air Force Base come in and evaluate your evaluate your design and give feedback, um, so that again you can understand how the airplane is performing. I'll definitely give you feedback on the design. So the first pass of your design will be I'll fly it. I'll go through yours first. And then if it, hopefully, again, almost all the time, it'll come to a stage where it'll be ready for the test pilots to fly and then give you feedback. Now, again, it is a very unique experience to get feedback from test pilots that no other schools, in the country has this type of experience. Maybe Air Force Academy, but uh, even then, I don't think actual test pilots come to the simulator to give feedback. But you know, that is something that we've been doing for the last 10 years since we had the simulator. And I really hope that you make use of that opportunity. So that is our course schedule. Uh, and then here's kind of the layout. I use AI to design this. It may have some errors, but this is our semester in one page. We have two homeworks due every month because we are on a bi-weekly basis. There will be quiz every 2 weeks as well. Uh, but that's it. That's our progression. All right. So I'm going to stop this video now, and I'm going to talk about the design mindset in the next video. All right. All right. We'll see you in the next video.